Yeah, hi. Here is the probation review presentation. My presentation title is Experimental and Numerical Study for the Combustion and Shoot Formation of the Belgian Field. My name is Shan Xiao, and my supervisor is Tianbo and James Jukes. So here is my content. So my presentation is about Belgian field combustion chutes. So what is the Belgian fields? Uh, from from the review articles, I can find that there are many major fields, and I choose to explain five of them. The first is Fisher Chopshe synthesis using natural gas, coal, and lingulogic biomass as feedstock. The second one is hydroprocessing of renewable material from plants such as climb and soil or grasses. The third one is hydroprocessed renewable jets, HRJ. It's made from used cooking oil, and HRJ is same as hydroprocessed esters and fatty acids, HEFA. The first one is alcohol to jet, ATJ, or sugar to jet, STJ. So ATJ also includes to my review reports. ATJ is like its jet term alcoholization is created from a variety of different chemicals such as methanol, ethanol, butanol, and a long chain of different fatty-based alcohols. The fifth one is hydroprocessed esters and fatty acids. HEFA. The HEFA oil and fats from both plants and animal, including vegetable oils or animal oils. Yeah, here is the NVPM emotion characteristics of aircraft gas turbine engines burning at Belgian fuel plants. Yeah, and I will explain about the aromatic. As we know, the aromatic is one of the important parts for the Belgian fuel. The aromatic is part of particular matter PM. So we know that the formation of the first ring is circumvented aromatic from the pH. As pH formation is highly correlated to shoot formation. Aromatic has not a linear relation with carbon number. Yeah. And here is the high temperature shoot formation. So for the high temperature shoot formation, here is the for the right side picture, we can find that the hair reactant temperature lead to a high shoot formation. The alkanes are more sensitive to the temperature change than alkanes. The shoot oxidation may be lowered by higher reactant temperatures. So how about the global jets NVPM emotion inventories? As we all know, the global aviation particle motion mass emotion inventors offer assignments on avenue aviation uh, numerical vision particular motion particular matter emotion, especially the magnitude of NV particular motion mass motion. So the aromatic hydrocarbons in fuel are critical NVPM precursors. The aromatic free property of aeration budget the fuel lead to NVPMS and numerical emotion reduction. So in this picture, we can find that when the same engine thrust and different fuel types, the same fuel types, different engine thrusts. So this is the other picture about the ground idle condition use jet A1 fuel has the highest fuel frequency. So different sampling temperature are denoted using different color denoted using different colors. Yeah, here is the PIV examples for our PIV calibration. So for our Davis PIV system, Davis PIV system use Davis 10 software. And for the camera, we use the CX5 imager camera, and it's the resolution is 2440 times 2040. The Davis PIV kit have options to compensate 64 times 64, 32 times 32, 16 times 13, 16, and 8 times 8 pixels as an integration area. So different size integration area means the different uh, size for the picture, the integration window. So normally we choose 32 times 32 pixels. So if the integration window is so big, it will uh, let the system run slowly because the picture is big, the memory is very big. But if we choose a very small pixel integration window, that means it's very difficult to find the flow fields different between two pictures. So not too big integration window pixels, not too small integration windows. So we choose 32 times 32. And want to cover a prop value roughly 10 times 10 centimeter. And the other difficult thing for us is the laser need is a classic 4 laser device. So how to determine the delta T for the measurements? The delta T is adjusted by altering the frame rate and consequently the laser repetition rates. Here is how to why choose the 32 to 32 pixels to form the integration area. I want to cover a total prop value roughly 10 times 10 centimeter. The PIV integration is the common integration size for PIV is 32 times 32 pixels. The cross correlation process normally have the 50% overlap. For the each integration window have we choose 8 to 10 particles. So here is an example about the experiment of setup for PIV. So we have the PV and Davis platform. We have the flame grabber connect with camera and signal generator. Also the ND Yak laser 532 net meter 30 meter milli joints price mix. The infractive index matching liquids for the big liquid and the covered with the tank. The laser covered with probe volume and the sheets forming optics let the laser come to the tank. Here is a photo about the tank and the pump for the PIV experiments. So from the third part of my provision report is use the coflame code. So why we choose coflame code as a computational field dynamic tool to calculate the Belget's shoots. So the coflame is can calculate the mass, momentum, energy, gas phase, chemical species, and it runs Fortran 90 and MPI requires an internal compiler. It's also need to uh, run on the Linux workstation. So the shoot formation in linear diffusion flame. Here is the example about the low Reynolds Lambert conflict code and the same low Reynolds number experiment result. We can say that the coflame code is same as the low 20 to 80 Reynolds number, but in a high Reynolds number, the experiment result is lower than the conflame code result. For the alkane's flame speed at the same temperature and pressure condition, methane is the lowest flame speed. Ethane is the fastest. For the conjugate heat transfer model, the CHT model. The CHT is a mesh model for conflame code. CHT is implemented by the harmonic mean method to model the heat transfer between the field streams and the solid field top. CHT is a model in air stream and field top. We can say that the simulation with the CHT model produce satisfactory the shoot formation about prediction. The shoot prediction's lower sensitivity to alpha can be explained by difference in shoot formation mechanism on the wings. pH adsorption is the predominant mechanism on the wings for the CHT models on the right hand side, making shoot formation on the wings less sensitive to alpha. The contrast without addition pH production. HACA surface growth remains stagnation on the wings. For the no CHT model, look at the left part. Use the no CHT model can improve the prediction by increasing alpha. So here is another example about with CHT and no CHT mesh model. So from the left hand side, for the picture is the no CHT model, and the right hand side is with CHT model. CHT simulation means part of the field types is included in the computational domain. Here is another example of CHT temperature mesh model. The right part side is the picture of the shoot wing. The left hand side is the confirmed CHT model. So here is another example of ethane H3 pH model used in conflame code. So it is includes 149 species and 13776 reactions for the next kinetic model, opposite flow flame model made by Chemical software. One of the important ammonia field is N20. The new C2H4 NH3 pH model is use the coflame comb and can be run the C2H4 NH3 pH model. Here is a tech plot draft shoot detail use coflame code. The shoot measurement, the uh, shoot formation, and dP can be measured by the laser induced indecence system, TIREI system. The shoot volume fraction